Well, history, normally when we talk about history, we are talking about the story of humanity, the story of humans, the story of us, the story of our species. And often history books, if they're going to start at the beginning, they'll start at the beginning of writing several thousands of years ago. Well, you could go back a bit further, couldn't you, really? You could go back to the beginning of humans ourselves, when we evolved from previous forms. You could go right back maybe to the time of the dinosaurs. Well, I think if you're going to tell a story, why not start at the very beginning? And the very beginning would be the beginning of the universe. Well, what is the universe? The universe is basically everything. It's all space, time, matter, galaxies, planets, and stars. And it is absolutely gigantic. It's enormous. It's huge. Adjectives, there's no adjective big enough to describe the size of the universe. It's mind-blowingly massive. Let's try and get some sort of idea of just how big the universe is. Well, here is our home, your home, my home. Here is the Earth. You've probably seen before those models of the solar system, you know, where you've got the sun in the middle and they show the planets going around the sun. Well, actually, the sizes of the models, when you see them, they're normally basically kind of wrong. They're wrong because they have to be, because if you're going to make a model of the solar system and have the sun at its proper size and the planets at their proper sizes, the sizes would be something like this. Well, that doesn't seem like a problem. Look at the size of the Earth. It's absolutely tiny. It's just a dot compared to the sun. Well, it's not this near to the sun. If it was this near, the Earth would burn up instantly. In fact, if the sun was the size of a basketball, then the Earth would be about the size of a little tiny apple seed. And how far away would it be? If the sun was the size of a basketball, the Earth would be about 90 meters away. So to try and imagine that, if the sun were a basketball and you put it just right outside the sports hall in Bromsgrove, well, the Earth would be an apple seed about 90 meters away. That would be roundabout at the entrance to the Digby Jones building. Pretty far. And Pluto, which, poor old Pluto, it's not a planet anymore, that would be about 1.3 kilometers away from the sun. So you can see the sizes, the distances are gigantic. Something else. Did you know that light moves at a speed? Light moves at a speed of about 300,000 kilometers in 1 second. 300,000 kilometers a second. But we're about 150 million miles away from the sun. So light actually takes about 8 minutes to reach us from the sun. Here is our nearest star. This is a star. Our sun's a star, just like any other star. In fact, it's quite a small star. Here is our nearest star. This is a star which we've called Proxima Centauri. And this star is about 4 light years away. So light moving at 300,000 kilometers in 1 second takes 4 years to reach us from our nearest star. Well, stars are grouped together in massive things called galaxies. Here is a picture of the night sky, and the galaxy that we live in, we've called it the Milky Way. You can see in the night sky, you can see thousands of stars. Well, you can't see all of them. In our local galaxy, there are between 200 and 400 billion stars. Our galaxy, actually, scientists think, from the evidence they've got, they think it's a spiral-shaped galaxy. Here is a relatively nearby galaxy. So our galaxy is shaped something like this. We'd be in one of the arms of the galaxies here. So, galaxies absolutely gigantic. Billions of stars in them. Well, there are also billions of galaxies. Let's have a look at a few. So here you can see 3 galaxies quite close together. When I say close together, they're millions of light years apart. Galaxies actually themselves are grouped together. So groups of tens or hundreds of galaxies grouped together, we've called them clusters. And then these clusters are grouped into even bigger, gigantic structures of thousands of galaxies called superclusters. And then you have absolutely titanically enormous groups of galaxies, such as the Great Wall of Galaxies, which we're in, and that consists of millions of galaxies. And remember, each galaxy contains about 500 million stars. This is a view from the Hubble Space Telescope. It's called the Deep Field View. Every single blob of light you can see in this picture is a galaxy, and each of these galaxies contains billions of stars. It's absolutely mind-blowing. Scientists now, they might be wrong, but they are, they put a lot of work into it, and they've got a lot of evidence for it. So estimates today, there's probably around 100 billion galaxies in the universe. That's 100 billion written out with all the zeros. That would mean that there's about this many stars in the universe. Again, it's just such a big number, it's impossible to get your head around it. So, we get the idea that the universe is big, very, very big. It's also very, very old. And again, scientists at the moment, most estimates estimate the universe is about 13.7 billion years old. So it didn't exist forever. Most scientists now think that the universe had a beginning. What's the evidence? The beginning of the universe, actually, the sort of slang word for it nowadays, they call it the Big Bang. So the universe started at a tiny point and then exploded, and space and time got much bigger and much bigger. So why do scientists think that the universe actually had a beginning? What's some of the evidence? Let's look at some of the evidence. Well, this guy, he looks like a typical scientist. He's smoking his pipe. This is Edwin Hubble. Very smart guy, but like anybody who actually achieves anything, he wasn't just smart, he was very, very, very hard working. And he measured lots and lots of stars and galaxies with a very large telescope. And in the 1920s, he noticed something called redshift around the universe. Well, what's redshift, and how does that tell us that the universe is expanding, getting bigger and bigger? Well, light moves in waves. You know, when you see it, when you drop a rock into a pond, you see waves move away from where the rock fell. Well, light moves in waves a little bit like that. The waves of light also, they have wavelengths. So here you can see, here's a bit of a diagram. You can see some light here moving from red to orange to yellow to green. Well, some light has longer wavelengths. The wavelength is the distance from the top of one wave to the top of another wave. So longer wavelength light is red. And as you go and the waves get shorter and shorter and closer together, you can see the wavelength, the distance between the waves, is getting smaller and smaller. And in the visible light, you move from red, and as the waves get smaller and shorter, you move into violet light. Well, that's going to help us. So remember the idea of wavelengths. Longer wavelengths are in the red part of light, and the shorter wavelengths are down there in the blue and the violet. Well, we're going to look next at something called the Doppler effect. Have you ever heard, when, say, a motorbike is moving towards you, the sound goes a bit something like this. It's moving towards you, and it goes sort of, so as it's moving towards you, the sound is higher. That, as it's moving away from you, it goes, I'm sorry about the terrible sound effects there. But basically, when something's moving, the waves at the front get squashed closer together. So it's like a shorter wavelength. That's why the sound is higher. As something's moving away from you, the wavelengths get kind of stretched out, so the sound sounds lower. That's why, again, if you watch motor racing or things, you hear that sort of as something moves towards you and then moves away from you. Well, the same thing happens to light. If something is moving away from you in the universe, let's say a star or a galaxy, the wavelengths kind of get stretched, so they move more towards the long part of the spectrum. They go sort of more towards the red part, and that's called redshift. So if things are moving away from you, the wavelengths get stretched, they move towards the red, and that's called redshift. If something is moving towards you, the wavelengths get squashed together, just like in the Doppler effect, and we call that blue shift. Well, what Edwin Hubble discovered as he looked at things all over the universe is nearly everything we see in space shows redshift. That means that everything in the universe is moving apart. And of course, if everything's moving apart, if the universe is getting bigger and bigger and bigger, if you go back, it suggests that the universe came from something very, very small. Perhaps it had a beginning. Another piece of evidence for the Big Bang, the beginning of the universe, is something called, and it sounds a bit scary, the cosmic background radiation. Well, what's that? Basically, if you have a massive explosion, a huge, great big bang, you'd expect to see some leftover heat from the beginning, from that explosion. And that was what was found by these two guys, Penzias and Wilson. They were actually looking after some radio telescopes. These radio telescopes were looking out into the universe, and they were listening out in the universe for, you know, for radio waves, for things telling us about the things happening far away in the universe. Well, they found that there was waves coming from everywhere, and at first they thought our radio telescopes, they must be broken because they're pointing into space, and wherever we point them, we're getting waves coming in. Maybe something's wrong. Maybe there's like bird poo on the telescope. Well, they cleaned off all the bird poo, and it wasn't bird poo. Basically, what Penzias and Wilson were discovering when they looked out at every part of the universe, they were discovering the leftover heat from the gigantic explosion at the beginning of the universe. And that leftover heat from the beginning of the universe, from the Big Bang, that's the cosmic background radiation. The leftover energy from the Big Bang. Just before we finish, some interesting facts, which I think are absolutely amazing, actually. Did you know that you are made of stars? What do I mean by that? Well, hydrogen is the most common element in the universe. And all of the other elements in your body, things like carbon, iron, gold, you do have some gold in you, by the way, all of those elements are actually made in the middle of stars. They're made in the heart of stars. And when stars die and when they explode, they throw all of those elements they made out, and sometimes that cloud becomes a new star and new planets. So you are not only made of stars, you are made of exploding stars. Pretty interesting stuff. So let's have a quick summary. First of all, the universe is very old. We estimate nowadays about 13.7 billion years old. Light moves in waves, just like the waves you see when you drop a rock into water. The Doppler effect can help us to tell if something's moving towards us or away from us. Because if it's moving towards us, the waves get pushed together, so you get shorter wavelength. If it's moving away, you get the longer wavelength. And with light, that's called redshift. Things moving away from you show red shift. Edwin Hubble found that nearly everything in the universe has redshift, and therefore the universe is basically getting bigger. It's expanding. And Penzias and Wilson, two scientists, found out that it wasn't bird poo on their radio telescopes. They were detecting the leftover radiation from the birth of the universe. Well, just before we finish, I'd like to show you just a short video, and I think it really gives you some idea of the size and the scale of the universe. After that, try the quiz and good luck.